Okie dokie. Let's look at some statement problems. They say, which of the following assertions about functions is true? If b is in the range of f, then there exists an a in the domain which maps to b. So far that's sounding right. So what they're saying is like there exists some a value in the domain or some x value which is mapped to b. So if we think about like x values and y values in some, let me try that again, with a bunch of dots, right? And then y values with some other dots. And we have some a being mapped to some b. In other words, some input A creating some output of B, then B is in the range. So that's sounding right so far. So I'm going to go true, but then let's see if we can prove the others false. Values in the range do not depend on values of the domain. Now that's just false. Values in the range, in other words, the y values, they're saying the y values do not depend on the values of the domain or the x values. And that is false. The y values entirely depend on the x values. C, a mapping of overall GPA to student is a function. Now, this one's very strange. The best way I could think about it is this. If you have like GPA as like the x values, and then I guess to students as the y values, say you have like, 4.0, 3.5, whatever, just a bunch of GPAs, and then you have a ton of different students, right? There could be multiple students with a 4.0, meaning 4.0 as the input could be mapped to numerous students. In other words, one input could be creating multiple distinct outputs, which means that it would fail to be a function. You can't have one input creating multiple outputs, so that's the best way I can explain that. Hopefully that's the right idea to explain that being false. D, an element of the range cannot depend on more than one value of the domain. An element of the range cannot depend on more than one value of the domain. Hold on, let me read that again. Element of the range, so y value, cannot depend on more than one value of the domain. So I think that is also false, because if we have more than one value of the domain, say like if we have x equals -2, but then we also have x equals +2, both of those might map to a y value of 4. Considering the function, say like y equals x squared. If you plug in -2 into x squared, and if you plug in +2 into x squared, you get y equals 4. So that's why that's false, because they're saying you can't have one element of the range coming from more than one value of the domain. Okay, anyway, I'm doing my best here. These are kind of strange statements. So A is our answer there. Let's go through 4 more examples. Which of the following assertions is false in this case? So they say for f of x, or y equals f of x is uniquely assigned to y. Okay, uniquely assigned? Yeah, I don't know about that. Because you can have, again, multiple x values producing the same y value. So that's saying like there's a single x assigned to a single y, which sometimes is true, but it doesn't have to be true. Let's look at B. If B is in the range, then there may be 2 points of the domain which each map to B. That's exactly what we were just talking about up here. There's 2 points in the domain, so -2 and 2, that map to B, a value in the range, so the +4 in that last case. So that is a true statement. Again, we're looking for the ones that are false, or the one that is false. The values in the range represent dependent variable values. Typically, yes, that is the case. So the values in the range, or the y values, are typically the dependent variable values, whereas the x values are the independent variables. D, a function can take a value from the domain to only one value in the range. So if we're talking about an actual function, then it can take a value from the domain to only one value in the range. That is correct, because we can only have one x value we can only have an x value producing a single y value, say y1. But if that x value starts producing two different y values, that's what makes it not a function. So that's why they say only one value in the range, and then, they're talking about that's a function, right? So A is our false statement in this case. And let's keep going. Which of the following is false? Computing the area of a circle given the radius defines a function. Okay, computing the area of a circle given the radius defines a function. I think that's valid if you have just the radius, though. Computing the area of a circle given the radius as a function. So if you think about the area formula for a circle, we have pi r squared. And I guess what would make this not a function? If you had a single radius giving you multiple areas, but I don't think that's the case, because the radius can only be positive, right? And so if you just have a single, I guess what I'm trying to say is, like, if the radius is 3, you're not going to get 2 different areas. You're just going to get a single area, right? You're not going to get an area 1 of, like, 9 pi and then another one of negative 9 pi. That just won't make sense. And so I think just because a single radius could only produce one area, then that should define a function. I think that is true. All right, B, a mapping of student to overall GPA is a function. I think we did that, right? Mapping of student. Oh, no. Okay, so they had it flip-flop. So back here they said a mapping of overall GPA to student is a function. Now, a mapping of student to overall GPA is a function. I think that is actually true. So if they flip-flopped it, right? So they had individual students. Basically what that means is, like, if students are the x values and GPA is the y values, a student mapped to GPA, a student is not going to have multiple GPAs. In other words, like, a single input is not going to have multiple outputs, right? A student can't have a 4.0 but also have a 3.8. That just doesn't make sense. So it's definite that a student will only have one output, one GPA, which means that it would be a function, okay? C, an element of the range depends on one or more values of the domain. So an element of the range depends on, I think, just, oh, no, that's right. Yeah, an element of the range depends on one or more values. We might have had this one, I can't remember. I'm thinking that's true, though, because you can have multiple x values producing the same y value, the element in the range. So multiple x values producing the same y value. That's totally fine. D, the map that takes a time of day and gives what's on TV is a function. Okay, so a map that takes a time of day, so say like 4 o'clock, and gives what's on TV is a function. Now, the issue is at 4 p.m. being the input mapped to different, like, channels or different shows on at 4 o'clock. Well, at 4 o'clock, there are a bajillion different shows on. So there's, I don't know, Full House, and there's The Office, and then there's blah, 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 South Park, whatever. There's a bunch of different shows, a bunch of different outputs from the same input of 4 o'clock. So that is totally not a function. We're going to try that as our answer. That is our answer. That is false. I'm starting to get the hang of this. That was only 3. We have 2 more examples. Let's get into it. Which of the following is false? A function can take a value from the domain to only one value in the range. That is true. We've seen that before. A function maps values from the domain into the range. I think that's true. I mean, I don't see why not. I mean, a relationship definitely maps values from domain into range. I'm not going to overthink it. I believe that's true. C, they say the values in the domain of a function represent independent variable values. Values of the domain independent. That is true. That's the idea that x values are the independent variables. D, values in the range do not depend on values in the domain. That is an awful statement. Values in the range entirely depend on values in the domain. So this is a false statement. Let's do one more. Which of the following are true? Which of the following is true? Values in the range do not depend on values of the domain. False. False. Mapping of overall GPA to student is a function. I can't remember what we said about that. We've seen that, though. Overall GPA to student. I think that was the first one we saw, which was false. Yeah, overall GPA to student is a function. That's false. Thanks for bearing with me in this long video. I'll scroll through at the end to get a glimpse at every type of thing we saw. If B is in the range, then there exists an A in the domain which maps to B. I think that's true. A graph always defines a function. That is false. We've seen graphs that do not define functions if they fail the vertical line test, right? So we're going with C as true. Here's a glance at all the statements we saw. Bada bam, bada boom, bada bing, bam, bop. All right. Hope this helps. If you have any questions or other statements that pop up that I did not cover, please let me know. All right.